Hello and welcome back. In today's video, I'm going to be going over all of the 2025 AP Calculus BC free response questions. If you have any questions, let me know in the comment section down below. Otherwise, let's get started with question 1. So, in question 1 part A, we have to find the average number of acres affected by an invasive species from time t equals 0 to t equals 4 weeks. So what's our setup gonna be? Well, actually, C of t defines the amount of acres affected by an invasive species at a given time. So what we're going to do is we're going to integrate C of t from 0 to 4, and we're going to multiply it by 1 over the start bound minus the end bound. Actually, the end bound minus the start bound. So 1 over 4 minus 0, and you have to show this, by the way, so that they understand what you're doing. And we're going to integrate from 0 to 4 of 7.6 times, and I'll just put this in parentheses, 7.6 arctan 0.2 t dt, and that gives us an answer of 2.778. So what does that mean? That means so let's write 1a, the average number of acres affected by the invasive species from t equals 0 to t equals 4 is 2.778 acres. Now we have 1b. Find the time when the instantaneous rate of change of c equals the average rate of change of c over this interval. So how do we find the average rate of change of c? So what we're going to actually do here is write c of x is equal to, remove the dt, and write x. And let me put this here, and do this. And let's make sure that we're in radians, and we are. So let's just zoom out a bit, and here we go. And what we're told is we have to find the average rate of change of this over the interval 0 to 4. So we're going to do c of 4 minus c of 0, all divided by 4. And that gives us 1.282 as the average rate of change. But we have to find the time when the instantaneous rate of change is equal to that. What's the instantaneous rate of change? That's the derivative c prime t. So 38 over 25 plus x squared is equal to 1.282. Let's just hide this graph. The equals should not be down there. Let's just fix this. Equals 1.282. Now, we're going to set y equals 0 to try find the intercept. But as you can notice, I can't really find that well. So what you want to do is multiply the 25 plus x squared over to this side. And when you do that, you remove the denominator, and now you can notice that it does intersect. So that gives us a value of 2.154. That means that at t equals 2.154, the instantaneous rate of change of c of t is equal to the average rate of change of c of t. There we go. Now for 1c. Assume the invasive species continues to spread according to the given model for all t greater than 0. Write a limit expression to describe the end behavior of the rate of change and evaluate it. So how do we do this? So what you want to do is write limit as t goes to infinity. The drawing is not the best as I'm doing this on my mouse, but it will do. So we're doing t, and we're going to evaluate 35 over 25, 38, and we're going to be dividing this by 25 plus t squared. Now, when we evaluate this to infinity, we're going to be getting 38 divided by 25 plus infinity squared. And we know that 1 over infinity is equal to 0, so this is greater than that for every single value. This is less than that actually for every value of t, meaning that at t equals infinity, this is going to be equal to 0. So this equals 0, and that's how you evaluate the limit expression. Now we have part 1d. At time t equals 4 weeks after the invasive species appears in the fruit grove, measures are taken to counter the spread of the species, and the function a of t models the number of acres affected by the species over the time interval. And for what time does a attain its maximum value? So how do we do this? So any graph will reach a maximum value when the derivative of the graph is equal to 0. Now this could also mean it's a minimum, which is why we have to actually test the values, but when the derivative is equal to 0, it could either be a max or a min. So what's the derivative of a of t? Well, that's going to be equal to c prime t, but here, we're taking the derivative of the integral. But since we're doing that, all we have to do is treat this as 0.1 ln of t. We don't have to do anything with the 4. So that means our equation now is c prime of t minus 0.1 ln of t, and that is what a prime of t is equal to. Let's write that. A prime of t is equal to this. And so we have to find the maximum value of this. Luckily, we can just graph this. So I'm going to do 38 divided by 25 plus x squared. And what are we subtracting? 0.1 ln of t. So this is actually our graph. I'm going to delete all of this. And we're doing this from the interval of 4 to 36. Let's actually just write it here. 4 to 36. And so we have to find when it equals 0. So if we look over here, when x is equal to 0, or t, at 11.4417, our derivative is equal to 0. So that means there's either a max or a min there. So t equals 11.4417. So t equals 11.4417. But we're not done yet. All we know is that this could be a max or a min. What if at time equals 4 or time equals 36, we reach the maximum? So what you're going to do is you're going to test out all of these values. So t equals 4, t equals 36. And what you're going to do is just integrate them. Well, let's do that now. So we can go back here and we can write our function again. C of, let's write x is equal to 7.6 arctan of 0.2x. And what is our integral here? It's integral, so let's write z of x is equal to the integral from 4 to x of, what is it? 0.1 ln x. ln of x dx. And if we did like z of 5, for example, well, that doesn't work. You can't use it, x as an integrand. Let's just write r. And we put r here. There we go. So now how do we actually do this? Let's test out all of our values. So first we're going to be testing at time equals 4. So if we did c of 4 minus z of 4, we get 5.128. So let's just write that here. 5.128. We can do at time equals 36. What do we get? 36 minus z of 36. That gives us 1.74. So then let's test out 11.4417. 11.4417 and 11.4417. That gives us 7.316. So 7.316. So as we can see, after testing our endpoints and the value at which the derivative equals 0, and this is the only value in this interval, we've achieved a maximum value. So that means that a must attain its maximum value at 11.4417, and that maximum value is 7.316. Well, that's question 1. Let's move on to question 2 now. Question 2. A curve is defined by these polar equations. That's curve C by r of theta equals 2 sine squared theta for 0 to pi. And there's a semicircle that's just r equals 1/2 for 0 to pi is shown here. And remember, your calculator should be in radian mode, not degrees, because we're doing 0 to pi. So first, find the rate of change of r with respect to theta on the point of the curve, at the point on the curve when theta equals 1.3. So how do we do this? Let's do it. So we have r of theta, I'm just going to write r of 0, but this is r of theta, equals 2 sine squared of theta. So how do we find dr d theta? You just take the derivative, that's it. So we have r prime theta, or dr d theta, equals. Now remember the chain rule with this one. We're going to be doing the chain rule first. So 4 cosine, we're going to be doing 4 sine theta times cosine of theta, because the derivative of the inside, which was sine of theta, is going to be cosine theta. So r prime is going to be 4 sine theta times cosine theta. And all you have to do is plug in when theta is equal to 1.3. I have my calculator in front of me, which is faster, so I'm just going to do that. 4 sine 1.3 times cosine of 1.3. Let me just make sure my mode is in radians. And that gives us a value of, so r prime of 1.3 is equal to 1.031. 1.031 is the rate of change of r with respect to theta at the point on curve C when theta equals 1.3. Next question. Find the area of the region inside of curve C but outside of the graph of the polar equation r equals 1/2. So how do we do this? Well, you can notice that this graph is greater than r equals 1/2 for this theta to this theta. But from here to here, it's actually under. So we want to find these points of intersection. So let's do that. So we have 2 sine squared theta, 2 sine squared x equals 0.5. And let's try and solve for this. So we need to solve for theta. So if I set my step to x, we can see that at pi equals 6, we can see that pi over 6 and 5 pi over 6, those are the bounds for our intersections here. So this would be pi over 6 and this would be 5 pi over 6. So what do we do from here? Well, we just take the integral. So what's the integral for a polar graph? It's 1 over 2 times the integral from your first bound to your second bound of r squared theta. So let's actually plug in our values now. We're doing this from pi over 6 to 5 pi over 6. And what are our equations? It's going to be 4 sine squared theta. That's 2 sine squared theta, and you have to square that all. So 2 sine squared of x squared. Make sure to put this whole thing in brackets. Minus, well, 1/2 squared is just going to be 1/4. So we have 1/4 dx. And that gives us a value of 2.0667 or 2.067. So that means that the area that's inside curve C but outside of this semicircle, B, so that's going to be 2B, is 2.067. Next, part C. It can be shown that the derivative for curve C is equal to this. That dx d theta is equal to this. For 0 is less than theta is less than pi over 2, find the value of theta that corresponds to the point on curve C that's farthest from the y-axis. So what does that mean if we check over here? The farthest point from the y-axis is going to be around here. And let's note that this actually has a vertical tangent line. And if we recall, the slope there is going to be dy over dx. But we don't have y or x. But what we do know is that dy over d theta divided by dx over d theta is actually equal to dy over dx. So what we can see here is that if we want a vertical tangent line, we want the denominator to be equal to 0. And luckily we have dx d theta. So we need to find the value of theta that makes this value equal to 0. So let's do that. We have 4 sine theta cosine squared theta. So 4 sine x cosine squared of x. And we have that is equal to 2 sine cubed theta. And we want to find where they intersect because that gives us the value when it's equal to 0. Because we set this equal to 0 and we add this over. So 2 sine cubed theta. 2 times sine of x cubed. Let me just delete all of these other graphs since they're from other questions. Well, this is from the current one. So when we do this, and we're trying to find from 0 to pi over 2, we can see pi over 2 is here. They intersected this value, meaning that at theta equals 0.955, so let's just write that here. That's 2c. You can't really see it, well, there you go. At theta equals 0.955, we have the point farthest from the y-axis. And there we go. The answer is just theta equals 0.955. And now the final question. A particle travels along curve C such that d theta dt is constant 15 for all times t. Find the rate at which the particle's distance from the origin with respect to time when the particle is at theta equals 1.3. Well, that's what we have to find. The rate at which the distance from the origin changes when we're at theta equals 1.3. Well, at this question, when we did dr d theta, all we had to do is take the derivative like that. But what if we had dr dt? Well, all we have to do is do one extra step. So we have dr over dt is equal to, and we do all of our derivatives like normal, but we have to remember to multiply this at the end by d theta dt. So we still have the same 4 sine theta times cosine theta, but now we're doing times d theta, so d0 dt. And now, where have we seen this before? We know the value of this from a previous question. That is equal to 1.031. So all you're doing here is plugging in this. This is 15, so you're just going to be doing 15 times 1.031, that's 15.465. So dr over dt is equal to 15.465. And there you go, that's your answer for 2D. Now that we're done with question 2, let's move on to question 3, the non-calculator section. So, 3a. Approximate r prime of 1 using the average rate of change over this interval and indicate units of measure. So what's r of t? This is the rate at which a student reads. So how do we find r prime of t? What we have to do, and we're approximating, by the way. So this is the same as the average rate of change just over 0 to 2. So we're going to be doing r of 2 minus r of 0, and we're going to divide all of this by 2. And remember, there's no calculator on this section, so I won't be opening decimals. So that means we have to do 100 minus 90, and we divide this by 2. This gives us 5. But what are our units of measurement? This is words per minute, but we're finding the derivative of that. So that means that this is words per minute squared, or words per minute per minute. Now we're on to B. Let me just write A up here. Must there be a value C for 0 is less than C is less than 10, such that r of C is equal to 155? Justify your answer. Well, let's look over here. Our starting value at t equals 0 is 90, and our ending value at t equals 10 is 162. And we're given that this function r of t is a differentiable function. Well, what does that mean? If we have a differentiable function, that must mean it's a continuous function. Continuous function. And we know that r of 0 is equal to 90, and we know that r of 10 is equal to 162. Now what does this mean? This means that r of 0 is less than 155, is less than r of 10. Now, since we have a continuous function, and since we have a lower bound that's less than the number that we want, and a higher bound that's higher than the number we want, we can apply the intermediate value theorem. So as per IVT, since we have a continuous function, and you're going to state that r of 0 is less than 155, r of 10 is greater than 155, there must exist a value C where r of C is equal to 155. Now we're on to C. Use a trapezoidal sum with 3 subintervals in the data to approximate the value of 0 to 10 integral of r of t. Now, how do we do this? Well, remember your trapezoidal sums and our interval lengths. The area of a trapezoid is a plus b times h divided by 2. Now, what's our height here? The height is the length of your subinterval. A is 90 and b is 100 for like this example. So let's start with our first trapezoid. At time equals 0 to 2, so our height is 2, and our heights are 100 plus 190, 100 plus 90, and we're dividing this by 2, plus our next length is 6 times 100 plus 150 divided by 2, plus our final one of 2 times 150 plus 162 divided by 2. Well, 2 divided by 2 is 1, so this is just 190 plus 3 times 250, that's going to be 750, and this is 150 plus 162, that gives you 312. Now all we have to do is add this up. What is 190 plus 312? That's going to be equal to 502 plus 750. 502 plus 750 is equal to 1252. And this is words. So that means from the integral of 0 to 10 of r of t is approximately equal to 1252 words. Now that we're done with that, let's move on to part D. A teacher also starts reading at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the teacher reads is modeled by a function w defined by this. And based on this model, how many words has the teacher read by the end of the 10 minutes? Show the work that leads to your answer. Now let's actually do this. So we have to find the amount of words that the teacher has read, but we're given that this is the rate at which the teacher reads. If we integrate the rate, then we get the amount. So we're going to integrate from 0 to 10, and we're going to write our function here. So our function is going to be, let's close this. Our function is going to be right here, which is negative 3 over 10 t squared plus 8t plus 100. Now what is the antiderivative of this? The antiderivative of this is going to be, so it's going to be t cubed divided by 3. That gives us negative t cubed plus, that's going to be t squared over 2. So we're going to get 4t squared plus 100t. And now that we have our bounds, 0 we know is going to be canceling out with all of these because it's going to be 0 plus 0 plus 0. So then what we're going to do is just have to plug in 10. So we're going to be doing negative 1,000. Am I reading that correctly? Yes. Negative 1,000. Oh, it's divided by 10 by the way. So this is divided by 10. I don't know how I missed that. So this is actually going to be negative 100 plus 4t squared, so that's 4 times 100 plus 400. And our final thing is just 100 times t plus 1,000. This gives us 900 plus 400 is equal to 1,300 words at the end of the 10 minutes. Well, that's question 3 done. Let's move on to question 4. The continuous function f is defined on this closed integral, so negative 6 to 12, and the graph of f consisting of 2 semicircles and a line segment is shown in the figure. Let g be the function defined by g of x is equal to this integral, 6 to x of f of t. Find g prime of 8 and give a reason. Well, let's see. What's my reason going to be here? I know that g of x is equal to that. Therefore, g prime of x is going to be, we're taking the derivative of an integral. So all we're going to be doing is plugging in the upper bound, since the 6 is removed by the derivative. So that just gives us f of x. So, since I know that g prime of x is equal to f of x, that must mean that g prime of 8 is equal to f of 8. So let's go here. F of 8 is 1. Since f of 8 is 1, that must mean that g prime of 8 is also 1. Let's just double check. Yes, it's 1. Next, find all values of x in the open interval negative 6 to x to 12 at which the graph of g has a point of inflection. Give a reason for your answer. So when does a point of inflection happen? And one way I like to think of this is the point of inflection happens when the max or min of the derivative graph exists. So we're trying to find it for g. We know that g prime is equal to f of x. So if I'm trying to find the max or mins of the g prime x graph, we can just look at the f of x graph. So there's a max here, there's a min here, and is there anything else we can look at? There is a minimum here. Because as we can see, now we can think about this when we take the second derivative as well. It's decreasing here, the second derivative is decreasing here and then increasing here, meaning that there is a point of inflection here. So for 4b, the values of x are negative 3, 3, and 6. Now for your explanation, you can say this. For there to be a point of inflection at a certain point, before that point the second derivative must be increasing and decreasing after, or it must be decreasing and then increasing after. So here, it's decreasing then increasing, increasing then decreasing, and then decreasing then increasing. So there we go, it's negative 3, 3, and 6. Now we're doing 4c. Find g of 12 and g of 0. Well, how do we do this? We know that g of x is equal to this, so g of 12 is going to be equal to the integral of f of t from 6 to 12. Well, from 6 to 12 is just a triangle. So we have a base of 6 times a height of 3. So 6 times 3 divided by 2 is equal to 9. That means g of 12 is equal to 9. Now we have to find g of 0. Now g of 0 is from 6 to 0. Now remember, 6 to 0 is the same as the negative integral from 0 to 6. So let's find the integral from 0 to 6. This is a semicircle. The radius is 3, so we're just going to do pi r squared divided by 2. So pi times 9, that's 9 pi, divided by 2. But remember, it's negative. So it's negative 9 pi over 2, because the integral from 6 to 0 is the same as the negative integral from 0 to 6. Now we have to find the value of x at which g attains an absolute minimum on the closed interval from negative 6 is less than x is less than 12. So when does g attain an absolute minimum? That's when g prime is equal to 0. Now, it could also be a maximum, but g prime being 0, g prime of x being equal to 0, g prime being equal to 0 has to be true for a minimum to exist. And we want to find the absolute minimum value. So, when does g prime of x equal 0? So we know that g prime is equal to f of x, so it's here, here, and here. So our values, let's make a new text over here. X can be negative 6, 0, or 6. And all we have to do is test all these values. We know that the integral from 6 to 6 is 0, so 6 just gives us 0. we know that the integral from 6 to negative 6 is the same as the negative integral from negative 6 to 6. So let's just look here. We have negative 9 pi over 2 and 9 pi over 2. So these just cancel out. So if you do it to negative 6, that still gives you 0. Meaning that our only other answer is going to be at 0. So at x equals 0, g of x attains the minimum value of negative 9 pi over 2, and there's your answer for question 4. Now we're going to be looking at question 5. So let y equals f of x be the solution to this differential equation, and we have to find f double prime of 1 at the point 1, negative 1, so let's do that. We know that dy over dx is equal to 3 minus x times y squared. But I can also rewrite that as 3y squared minus xy squared. And let's just find the value of x equals 1 for the derivative quickly. So we have y prime is equal to, that's 3 minus 1 times negative 1 squared, that gives us 2. Y prime is equal to 2 when x is equal to 1. So let's differentiate this because this is y prime. But we need to find y double prime. So y double prime is equal to, first we're going to be doing the chain rule, so 6y times y prime minus, we're doing product rule here, so it's xy squared, so it's going to be y squared plus 2y times y prime times x. So let's just evaluate these. So y prime, we know y prime is equal to 2 at x equals 1, so 6y, so that's negative, so we're going to be doing negative 12 minus everything on the inside here. So what is that? We have y squared, which is 1. So 1 plus 2y, so this is going to be negative 2 times 2, negative 4. So we have minus 1 minus 4. This gives us negative 12 minus negative 3, which ultimately gives us negative 9. Y double prime at x equals 1 is equal to negative 9. Now we have to write the second degree Taylor polynomial for f about x equals 1. Now, how do we write a Taylor polynomial? Well, that's easy. It's about x equals 1, so we're just going to be doing f of a. Now remember, a is going to be 1. So f of a divided by 0 factorial plus f prime of a times x minus a plus f double prime a times x minus 1 squared, all divided by 2. Just this term is divided by 2. So what is that? We know that f of a is equal to negative 1. We know that f prime of a is equal to 2. So that's going to be 2 times, so plus 2 times x minus 1. And I prefer to leave it in the brackets like this. Plus, and we know that the second derivative is negative 9. So it's going to be negative, and I'm going to write negative 4.5 because it's going to be negative 9 divided by 2. So negative 4.5 times x minus 1 squared. And that is your second degree Taylor polynomial for f about x equals 1. So now we're on to part C. The second degree Taylor polynomial for f about x equals 1 is used to approximate f of 1.1. Given that the triple prime of x is less than 60 for all x, use the Lagrange error bound to show that this approximation differs from f 1.1 by at most 0.01. So we're using the second degree Taylor polynomial, and in order to use the Lagrange error bound, we just have to find the very next term. That means we're going to be using the third term, which involves the third derivative. So what is the third term? So that's f prime 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 x of 1. So f prime 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 of 1 times x minus 1 cubed, and we're going to divide by 6. Now, we know that f triple prime of x for our interval here is less than 60. So what I can write here is that f triple prime of 1 is going to be 60 or less. So we can just write 60 in for now. But if I have 6 here, I can divide this. So now I know that's going to be 10 or less, that the value of this entire fraction is going to be 10 or less. Well, what's x minus 1 at this point? We're going to be doing 1.1. So we know that x is going to be equal to 1.1 at this point. 1.1 minus 1 is equal to 0.1. Now, we can just make this a squared and remove the 10 here. So now what do we know? We know that the value of our fraction is going to be at most 0.1 squared. And guess what this equals to? 0.01. And the reason this all works is because for the third derivative, we said it's going to be 60 or less. So let's just rewrite that. f of 1 times x minus 1 cubed, all divided by 6. we said that this is at most 60. So if this is the maximum value we get, that means that this is going to be 0.01 or less. So since the third term of our Taylor polynomial about x equals 1 is at most 0.01 for f prime 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 x is less than or equal to 60, and you can just state the conditions again if you want. Since it's at most 0.01, we have shown that the approximation differs from f of 1.1 by at most 0.01. And now we're on to the Euler's method question. And this one is going to involve quite some multiplication. So using Euler's method, starting at x equals 1, you have to use 2 steps of equal size to find f of 1.4. So let's start writing. We need to make a table. We have our x. That was a horribly drawn x. We have our x, our y, and our y prime. So what are we starting with? I'm going to make this. So let's just increase this to like 14. Let's make it 20. So we're starting with the x value of 1. And we know that y is going to be equal to negative 1. And we know that at x equals 1, y prime is equal to 2. So what's going to be, so our next x value is 1.2, by the way. So what's our y value? So our y value is going to be equal to negative 1 plus, our step size is 0.2, so we're going to be doing 0.2 times 2, because that's our slope. And that gives us negative 0.6, because it's negative 1 plus 0.4. So what's this going to be equal to? We know that's going to be 3 minus 1.2 times 0.6 squared. What is 3 minus 1.2? That is 1.8. So let's write that, 1.8. And we're going to be multiplying by 0.6 squared. So now, in order to do this, I'm going to show you how I solve this. So 0.6 is the same as 0.036. So we're doing 0.036 times 1.8. So 0.36. And we're multiplying 1.8. So what you can do is you can just do 1.8, divide this whole thing, and you're going to get what? Let's write it as a text box. You're going to be getting 8, carry over 4, times 6, you're going to get 108. Dividing, you're going to be getting, that's 3 times 4, that's a 24. 4 carry over 2, you're going to be getting a 5. So that means you're going to be getting 8, 4, so you're going to be having 648. But make sure to bring your decimal over here. So it's going to be 0.648. So that's the value of 1.8 times 0.6 squared. But that's just the value of our derivative. So this is equal to y prime of 1.2. Now what we have to do is actually just apply it here. So what we're going to be doing here is negative 0.6 plus 0.2 times our derivative. So plus 0.2 times positive 0.648. That's all we have to do. So let's actually multiply it. It's not that bad. It's just 0.2 times 0.648. So you multiply the top by 2. Let's just do that here. 648 times 2. That gives you 6. Carry over 1. You get 9. And then you just do 2 times that. You get 1296. And remember, we're dividing by 10. So this is actually going to be divided by 10,000. And this is going to be 1296 divided by 10,000. And all we're doing is adding negative 0.6 to that. So you can rewrite negative 0.6 as negative 6,000 divided by 10,000. And you're just adding 1296 divided by 10,000. And what is that equal to? We're just going to do some simple addition here. We're going to do negative 6,000. Actually, I'm going to write this at the top. Yeah, negative 6,000 divided by 1296. And in order to do this, all we have to do is make this 9, 9, 10. That's a 4. That's a 0. That's a 7. That's a 5. No, actually, that's going to be a 4. So that means the value of y. So let's write the 4704 and put the decimal. This means that at f of 1.4, we have the value of y approximated with Euler's method to be negative 4704 divided by 10,000, or you can write down the decimal negative 0.4704. Now that we completed question 5, let's move on to question 6, the series question. A Taylor series for a function f about x equals 4 is given like this and converges to f of x on its interval of convergence. We have to use the ratio test to find the interval of convergence of the Taylor series for f about x equals 4. Justify your answer. So let's draw this. So we have x minus 4, and to use the ratio test, here's what we do. We do x minus 4 to the n plus 2 power divided by n plus 2 times 3 to the n plus 1. And you want to divide it by plugging in n, or you could just multiply by the reciprocal. So we have n plus 1. So we have n plus 1 times 3 to the n, all divided by x minus 4 to the n plus 1. Now, in order to use the ratio test, all we have to do is take the limit to infinity. So first, let's cancel some stuff out that we can. We have 3 to the n here. We just cancel this out. We have x minus 4 to the n, x minus 4 to the n here. We cancel this out. We have a 1 here. This is just going to be equal to a 1. And as we take the limit to infinity, n plus 1 over n plus 2, that's going to become infinity plus 1 divided by infinity plus 2. They're going to be the same value, so you're just getting 1 when you do n plus 1 divided by n plus 2, taking the limit as n approaches infinity, because that's what we're going to be doing. So in the end, all we have is x minus 4 divided, this is x minus 4 divided by 3. And now, how are we going to find the interval of convergence? We're going to do this is less than 1, and this has to be greater than negative 1. Now I'm going to go back to using the text box now. I know that negative 1 is less than x minus 4 divided by 3 is less than 1. Well, what does that mean? That also means that negative 3 is less than x is less than 3. But we also have to add 4. Let's put the minus 4 back in here. And now we have negative 3 is less than x minus 4 is less than 3. All we have to do is add 4, getting 1 is less than x is less than 7. But is this the final answer? No, because we have to check if it includes 7 or 1. So let's see. If I plug in 7, I'm effectively getting 3 to the n divided by 3 to the n. And that doesn't work out well, because then I'm just going to be adding 1 the entire time. So that's why 7 can't work as a value. But if x is equal to 1, then we have negative 3 to the n divided by 3 to the n. That just makes it negative 1 to the n. And if we have negative 1 to the n, then our Taylor series is an alternating series. And we know that this is going to converge, because negative 1 over n converges, and this Taylor series is going to be smaller than the series of negative 1 over n for every single value, because of this plus 1 in the denominator. So that means that by the comparison test, to an alternating harmonic series, we know that this converges if x is equal to 1. So that means our final interval is 1 is less than or equal to x is less than 7. If you're writing it using brackets, you're going to write it like this. 7 is this. So that's A. Now we're going to be doing B. Find the first 3 non-zero terms and the general term of the Taylor series for f prime. Well, how do we do that? One simple thing you can do is, you notice the x term is here. You just take the derivative here. Remember your simple power rule. Your simple power rule is, you take the exponent, you bring it to the front, and you subtract 1 from the exponent. So let's do that here. We bring down the exponent of n plus 1, and we subtract the exponent at the top by 1, giving us this. And this is all divided by n plus 1 times 3 to the n. But what you can notice is that the n plus 1s actually cancel out. So that means the derivative for f prime is equal to x minus 4 to the n divided by 3 to the n. And now we have to find the first 3 non-zero terms. Well, all you have to do is actually just plug in the values of n. So it's about x equals 4. Okay, so all we're doing is just x minus 4 over 3 plus x minus 4 squared over 9 plus x minus 4 cubed over 27. Let's expand this, and that is the first 3 terms of the general, this is the first 3 non-zero terms of the Taylor series, and we have the general term over here. So now, The Taylor series for f prime describing part B is a geometric series. That's correct. Our common ratio is x minus 4 over 3. For all x in the interval of convergence for the Taylor series, show that f prime of x is equal to x minus 4 over 7 minus x. So, how do we do this? Well, remember the equation for the sum of a geometric series. That's equal to a, where a represents your first term, over 1 minus r. So what is the first term here? The first term is x minus 4 over 3, because if you plug in n as 1, you get x minus 4 over 3. So let's just write that. So x minus 4 divided by 3 is my first term. And what's 1 minus r? Our ratio is x minus 4 over 3 again, so x minus 4 over 3. Now, what happens if I multiply the top and bottom by 3? That gives me x minus 4 over 3 minus the quantity of x minus 4. And can you guess what this is equal to? X minus 4 divided by 3 minus x minus negative 4, that's equal to 7. Therefore, we've shown that f prime of x is equal to x minus 4 divided by 7, because 3 minus negative 4, minus x. And now we're on to 6d. It is known that the radius of convergence of the Taylor series for f about x equals 4 is the same as the radius of convergence for f prime about x equals 4. Does the Taylor series for f prime described in part B converge to this? This is what we got in part C at x equals 8. Give a reason for your answer. Well, remember that here, this is for all x's in the interval of convergence for f prime. And the interval of convergence is when this becomes a geometric series. So let's say x is 2. Your common ratio is going to be less than 1, greater than negative 1. So this converges. This functions as a geometric series. But let's see what happens if we plug in x equals 8. If we plug in x equals 8, we get 4 to the n over 3 to the n. And 4 over 3 is going to be greater than 1. Therefore, if x is equal to 8, then our common ratio for the geometric series is 8 minus 4 divided by 3 is equal to 4 over 3. Since this common ratio is greater than greater than 1, our function f prime of x will not converge to x minus 4 over 7 minus x, as it is no longer a geometric series where the infinite geometric sum formula can be applied. Remember, you can only use the formula, the a over 1 minus r, if your ratio is less than 1 or greater than negative 1. Anyways, that's every single question for the 2025 AP Calculus BC questions. If you have any questions, let me know in the comment section down below if you want clarification or you want help with a specific question. Otherwise, goodbye.